We're now going to split into two tracks. Both tracks are for everyone to enjoy. Track 1, the executive track. It includes use cases by and for executives. Track 2, Attack Vectors Explained, provides a technical approach focusing on Pentera Labs research. For this next session, let's switch things up a bit. There's a lot changing on the detection side of security. Please welcome Mauricio Velazco, Principal Threat Research Engineer at Splunk, to share things from his perspective.
Hello, everyone, and welcome to my session, Detection as Code, Test-Driven Detection Development. My name is Mauricio Velazco, and in this session, we're going to be talking about the importance and the evolution of detection programs and how sophisticated teams are applying software engineering concepts to the threat detection practice. Now, we could talk hours about this topic, but since we only have 15 minutes for this session, we're not going to get that far. So especially today, I'm going to want to focus on the value that security validation and automated security validation adds to a detection program. Okay, so let's start. First, let me introduce myself real quick. Like I said, I am Mauricio Velazco. I'm currently part of the Splunk threat research team. And I love to talk about security and connect to people. So if you are on Twitter, follow me on Twitter. And my areas of focus include detection engineering, threat hunting, and adversary simulation. So if you're interested about any of those topics, I encourage you to visit my GitHub page where I have talks, tools, etc. That's enough about me. Let's move on to the first part of this presentation. I first want to talk about threat detection. Let's quickly define it. What is threat detection at a high level? I think it's the capability that security teams have to quickly identify threats which may be targeting our networks, our applications, our endpoints, our cloud providers, or any other assets that we have in our environments. I think security teams have realized that we're not going to be able to stop attackers from breaching our networks. No matter the amount of prevention controls that we set in place, attackers will find a way to bypass them. And that's something that the breaches in the past years have proven. So because of this, we realized that we need to not only try to prevent attacks, but maybe detect them after they have gained access. And that's why over the past decade, threat detection has become business critical. Organizations have really matured in this space. And we are deploying detection programs. We have people working on them. And we have moved on from I remember when I used to run a security team, I think we have evolved from in the threat detection space where before, 10 years ago maybe, we used to simply just buy shiny boxes that had a black box and could detect certain attacks, but we couldn't change how this detection worked. And so we have moved away from that to deploying robust detection programs where we're ingesting telemetry, logs from endpoints, from cloud, from networks. We're centralizing all this telemetry, and we're actually creating our own rules. So it's no longer a black box. We have teams that are creating new rules, maintaining rules that are specifically custom to our environment. Now, of course, this practice has a lot of challenges, right? Again, we could talk hours about the challenges of deploying a detection program. But I want to focus on a couple of metrics that a security company, the results of a research a security company did. So what Cardinal Up did is they talked to several companies that had detection programs, and they looked at their detections and analyzed them and see which ones were working or not. And they had a lot of takeaways, but I would just want to focus on two. First one, 95% of the tickets were generated by only 15% of the rules. So this is interesting. This could tell us a lot of things, right? But I think the most important one is that perhaps detection rules are not properly tuned to fit their environments, and this is why they have a high false positive rate. So I think this tells us that the quality of the detections needs to be improved. Second metric is 25% of detection rules are broken. This is probably the most impactful for me. This means our detections are just not doing what they're supposed to be doing. And I think this makes a lot of sense because typically, let's say you look at a new threat and your detection team creates a rule. Okay, but how do you know that rule still works after 60 days, right? I think that's a challenge that a lot of organizations have. How do you know if all your detections are working or not? How do you answer that question? And as I was saying, we have evolved in deploying detection programs. And I think where we are now, what sophisticated teams are doing is they're deploying what we're calling detection engineering programs. So let's talk a little bit about this. Detection engineering program is a continuous process of building, deploying, tuning, as well as operating detection analytics while applying engineering concepts. I think this is key. And the key word here is engineering. I think what we're doing is we're borrowing a lot of concepts, a lot of practices from what software development has implemented in the past, 20 to 30 years, and we're applying them to the detection problem. And for example, that means leveraging the version control to store detections. That means implementing DevOps practices like automated workflows with CI/CD, and that means testing our detections, etc. So let's talk about this, and specifically a few points that I want to bring up. And if we consider a modern software development process that implements DevOps and implements CI/CD jobs, it looks like this high level, right? Like as soon as a developer commits a change, an automated process kicks off that starts a build in a test environment. And if the build is successful, that's the first check. That means that the code did not break anything on the build process. Maybe syntax error, maybe, who knows. So once that validation passes, then we move on to running the unit tests. So these are tests that developers have created for their code. And that's the second validation. If that passes, we are ready and we are able to deploy to production, right? So let's apply this to the detection program. Oops, sorry about that. Let's apply this to a detection program and think about this. Let's say a detection engineer is working on a new detection idea and he thinks he's ready and he wants to commit this new detection. Once he commits a detection, an automated workflow will analyze this detection and perform the first validation. For example, a simple example is the syntax of this query, of this detection. Depending on the technology that you're using, you may be using Sigma or Splunk query language or Custo or SQL, doesn't matter. Each of them has a syntax, and the syntax, if it can break, right? The detection may be wrong. So this is the first validation that we could do. Is the syntax valid? And this could be automated, right? Like we can provide that feedback and automate to the detection engineer using CI/CD jobs. Once the validation passes, this initial validation, we can move on to testing that detection. Now, this is the most interesting piece here, because how do you test that detection? Well, we need a lab environment that mimics a real environment that has a proper login, and we need to execute the attacks and validate that the detection is able to detect what it's supposed to detect. Like I said before, a lot of things could be broken with detection. This is our way to validate that. And I think the key here and what I want to focus on from a detection engineering program and from the detection as code is the testing piece, because this is where the automated security validation can help us. Now, detection as code principles, let me talk about this real quick, high level. If you're thinking about deploying detection as code, I think these are the 4 pillars defined by Jose Hernandez and Patrick Varese at RSA 2020. First, we need a detection language that is designed to make the detection development process as easy as possible and can increase also the detection development speed. Now, all these files that you've written in your detection language, for example, a YAML or JSON or something like this, need to be stored in version control systems such as GitHub or GitLab. It will help you store the detection rules and also track changes over time. Then we need automated workflows, specifically CI, continuous integrations, continuous delivery systems like GitHub Actions, like Jenkins, like Circle CI. This is going to allow you to run automated scripts, which are you can use to validate your detections. And then finally, test-driven deployment. What is this? Well, this is another interesting practice that we can adapt from software engineering. And test-driven deployment is the concept of developing the test before actually developing the code. Now, if we translate this to the detection world, this means executing the attack, simulating the attack before we try to write a detection. And that makes total sense to me, because how can you detect something if you don't know how it looks like on your logs, right? So you first have to simulate the attack to generate the data set of the execution of that attack to then try to create a detection. It's just natural, right? This is the first that you need to do: simulate the attack, generate the attack. And of course, we need tools to do that. Or, well, yeah, we need tools and people that know how to manage these tools to generate those attacks, to generate that data set. This is key. And what does it mean to test your detections in an automated workflow? Let me talk a little bit about this. Well, we first need to build an environment that mimics a real environment. For example, if you're looking to create detection or test detections against your cloud tenants, you need to build an environment that looks similar to the one that you have in production, with the same services, with users, with resources, and of course with the proper login, right? Like if you are logging to a SIM, whatever it is that you're using, what technology you're using, you need to hook that up. Once you have an environment ready, then you can simulate the attacks. And this is key. What do we need to simulate the attacks? Well, we may need offensive tools, right? Like open source tools, maybe commercial tools, or also we could leverage automated secure validation tools. Then we run the detections based on that, against that environment, based on those attacks, and we can create a report and have an idea of how many of our detections are working, how many are failing, and then we have our checklist of detections that we need to fix. It sounds easy, right? But this is not something a lot of companies are doing, unfortunately. So this is short, of course, a really short session, and we're almost hitting 15 minutes here. And I want to close the session with just 2 takeaways to think about. One, if you have a detection program or you're considering to deploy a detection program, applying engineering concepts, engineering practices can improve your security posture by a lot. I think this is just the next evolution of detection programs. And we all need to be doing this. It's going to definitely improve a detection program to treat your detections as if they were code. And finally, to shift to a test-driven development, our security teams need the capability to replicate attacks. This is key. Like, how do we get there? Like, typically this offensive knowledge is only what red teams have. But what I'm saying is that detection teams need to be able to replicate attacks so that they can test their detections, they can write detections. So that means either hiring people that have offensive capabilities, offensive skills into our detection teams so they can execute the attacks. Or this could also mean buying a tool that does this, right? And tools like automated security validation. So regardless of how we do this, we need to be doing this, I think, for our detection programs to be successful. So that's it for me. I hope you enjoyed this session. And if you want to keep chatting about this, you can ping me on Twitter again. And I hope you enjoy the rest of your conference. Thanks a lot. You guys have a great day. Bye.
It certainly is interesting how automation can be used across multiple security practices in an organization. Thank you, Mauricio.